Hello everyone, my name is Ahmed Abu Khadra. I am a PhD student from the German Research Center for Artificial Intelligence. In this work, I will present THOR-Net, an end-to-end Graformer-based realistic two-hands and object reconstruction with self-supervision. Realistic reconstruction of two hands interacting with objects is a new and challenging problem that is essential for building personalized virtual and augmented reality environments. Many works focus on a single hand reconstruction, but very few focus on two hands and object joint reconstruction. Using THOR-Net, we are the first to estimate realistic personalized two hands shapes. Given a single RGB frame, THOR-Net estimates a 3D hand and object pose along with the realistic 3D hand shape and object shape. To extract 2D information from the RGB frame, we adopt a robust object detection model called the keypoint RCNN, which produces two main outputs. The first output is the set of heat maps that describe the location of the 2D pose within the image, and the second output is the set of 2D feature maps for the region that contains the hands and the object. To estimate the 3D pose, we utilize the Graformer, a transformer architecture combined with graph convolution for 3D pose estimation. This network has shown great performance in 2D pose to 3D pose lifting. The input to the Graformer is the estimated heat maps and it produces the 3D pose. The second branch of the network is a novel coarse-to-fine Graformer which estimates the 3D shape of the hands and the object. The input to this branch is a graph representation which is initialized as follows. First, we pass the feature maps extracted from the keypoint RCNN through a two-layer perceptron to produce a feature vector of size 2048. This feature vector is replicated and added to each node in the pose graph. In addition to the feature vector, we also append the corresponding flattened heat map to the node representation. After the graph initialization, we pass it as an input to the coarse-to-fine Graformer that generates a 3D shape for hands and objects. The shape network consists of an input graph convolutional layer that compresses the node representation. After that, there are three pairs of graformers followed by unpooling layers that reduces the number of features while increasing the number of nodes until it reaches the final shape. To create a realistic hand shape, we propose a novel self-supervised photometric loss which allows to directly regress the texture for each vertex in the hand's meshes. To this end, we jointly estimate the vertex 3D location and its texture by projecting it to the image plane using the camera intrinsics and penalizing the difference between the vertex texture and the underlying pixel RGB value. The meshes of the objects don't have a consistent topology, which is a challenge in creating a graph adjacency matrix for the coarse-to-fine Graformer. To solve this, we represent objects using a sphere by learning the deformation from the sphere to the target object. The learning process depends on the chamfer distance and the smoothness loss. Here you can find some examples of the original objects and their spherical representation. Our method reconstructs reasonable 3D hand shapes and object shapes on two public benchmarks, HO3D and H2O. Here are some reconstruction results from our pipeline. We observe jittering in the estimation because there are no temporal constraints, which we plan to address in our future work. Here is another example of the reconstruction from the H2O dataset. And here we show the estimated hand texture using photometric loss. We also compared our results qualitatively with the state-of-the-art method and show that our method captures better details on challenging sample images. Our method achieves state-of-the-art results on two benchmark datasets, HO3D and H2O. Finally, our network also estimates the texture of objects. We observed a smoothing effect in the estimated texture, which we plan to address in our future work. Thanks for watching.